Hey everyone, today I'm going to be showing you how to set up this update to our building where we now have doors on the first level, and I can specify how many total doors. So if I want 3, I can have 3. If I want 1 door somewhere, I can go ahead and set 1 and just have it recalculate. There's 1 door on this building. If I want more doors, I can do the same thing. I can just specify a number, have it recalculate. There's 1, 2, 3, 4, 5, 6, 7, 8. There's our 8 doors. It does need to be recalculated for the time being. So if I was to change this to 2, it doesn't automatically recalculate it. So I do need to force update it. But there you go. There's 2 doors now on this building, and it doesn't affect any other floors. And we now have a floor on every single level, as well as a roof. Now I'll show you how to do all of this. Let's get into it. So here we are back with our building. We're going to be doing part 2 now. And we're going to start out by opening up our PCG graph. And what I've discovered between our 2 sections is this transform points that we have here to reset our rotation, because originally, if I don't reset the rotation, you can see they're inverted, is actually an easy fix. And we can just do that by going to copy points and changing the rotation inheritance from relative to target. And you can see it is now facing the correct direction. Now, we still have the problem of the offset, and that I have not figured out as of yet. But what we can do now is plug this in, reset our rotations here, and the offsets are now different. So if we go to our BP building, instead of this complicated setup, what we're going to do is delete all of these, keep the -1, but we're going to recombine these pins, so that way they're actually vectors, and then we're going to multiply the vectors by -1, just all of them, which is a lot simpler. And if I compile that, there you go. So now we're back to having this stuck to where we want it in all axes, but we're now no longer doing more complicated math. This seems a lot simpler and cleaner, so let's go with that. Now, what I want to work on next is getting our doors in, because right now on all sides we have windows, right? We have windows, and we can specify that random meshes will be doors if I wanted to. For example, if I was to add another index here, I can go into my mega scans and find ourselves a door. Right? And if I plug it in, we have, well, a door. Obviously, this is not the same kind of door that we were using. This is just a random door I grabbed. But you can see that we don't want doors everywhere, right? So what I want to do is swap out a random point on the first floor with a door. So that's what we're going to do. But I don't want to have it where I need to bring in a cube. So a common way of doing this is by having some kind of actor in your level with a tag. And as long as it's overlapping, right, then this would be a door. Or if I place it here, this would be a door. What I want to do, and what I've figured out how to do over the past week, is how to randomly select however many points you want out of your selection. So what we're going to do is these exteriors, we're going to use these, and we're just going to filter out with a blueprint variable that we can just set here, how many of these bottom meshes are doors. So to get started with that, what we're going to do is actually make our own custom PCG node to be able to filter out things the way we want. Instead of creating one from very scratch, we're going to use one as a reference. So what I'm going to do is drag this execute blueprint out here, and then I'm just going to select a random one here. And all I'm doing is to select it is just to navigate to the correct folder. So I just click the folder icon, and it will navigate me to the correct location. Now, you might be in the deprecated folder, in which case go out one to the BP elements folder. You can see it's right now we're in procedural content generation framework folder. And what we're going to do is use the set point color as our base. So I'm just going to duplicate this, and I'm just going to call it select random points. And I'm going to just scroll up, and I'm going to go ahead and just move this into our PCG folder. So here's our node, and we don't need this guy anymore. We can delete it. And if I was to drag this into our scene, you can see it has all the regular set point color information, but now we can go ahead and customize this. So let's go ahead and open it up. So when you open it, you're not going to actually see anything. There's nothing in the event graph. Everything happens on these nodes. So execute with context is basically your construction script. So if you double click on that, this is the path for just the color variation. So effectively, if I was to maximize this. So what we're doing here is it's getting all its inputs. And then for each input, it's getting the information from the points of that input. And by input, I'm talking about this node, this right here. You could, of course, when you create a custom one of these, you can have multiple inputs. But this is just going through all your inputs and then getting the information from there. It's casting it to spatial data. This is just a PCG thing that I guess needs to be done. Getting the data from those points. And then in this case, it's going to a loop, and then it's effectively adding it to the export tagged information that it needs. A lot of this is kind of like cookie cutter, what we need to do to have it work. And this point loop is point loop body flow control. So if I double click here, you can see each point goes into a set members node where it sets the color of the points based on the variable that in this case is exposed. So if I was to go to here and I drop this down, you could see everything here is exposed, and I can go here and linear color here is exposed, right? So I can set the color of the point right in here if I wanted to, but we're not going to be doing all this. We don't need this section. We're going to be cleaning this up. So let's change some stuff. Starting with this third one, node title override. So all this is the actual text that appears right here when you drag the point in. So if I was to change this to select random points and then compile it, you could see in our graph, it is now renamed to select random points. Very simple. What we also want to do is go under class defaults, and over here, you see you have asset info. So currently it is exposed to library in category color. We don't want it to be in category color. We want it to be in category custom. Then if I compile it and I go back to our PCG building, on our left side here, you could see under custom, we have select random points. So if I wanted to now, I can just drag this in from here. Perfect. Now, if you don't want it appearing here, you can just go in here and uncheck exposed to library. And then when you compile and save it, it will clear out of this menu. But it's convenient that we can have all our custom nodes right here handy. So I can just drag it in at any point. Now, if you want to ever edit one of these blue nodes or select it, you could select it and press this folder icon, or you could just double click on it and that'll also open it up. Let's go ahead and get started with our actual setup. For this, let's clean some stuff up, starting with the fact that we do not need this point loop. We're not going to be using this, or we're not going to be using this target actor set. Go ahead and clear these out. We can go ahead and delete linear color and go ahead and click yes. And we're deleting the loop body entirely. So we're keeping this information here. We're keeping all this. This is great. Let's keep this here. And instead of this large line going in, I'm just going to search for get in context. And we're just going to plug this in here. So a lot of this, thankfully, is now done for us. So it makes it a lot easier. Now, just so I don't have to actually drag these around everywhere, I'm going to right click and promote this to a local variable. And you can see it's called PCG point data. So I'll just call it that. Plug this in to our set node. And then from here, we're going to get the points. And you want to get the plural one. You want to get all the points, not a single one. I'll go ahead and drag this to the side. And from here, I'm also going to right click and convert it to a local variable. And I'm going to call it PCG points. Plug this in. Let's get both of these set. Now, basically, this has the full list of all the points are there. The way we're going to have this set up is it is going to check if the amount of points that I have entered. So if I enter in 4 in the blueprint, it's going to pick 4 random points and change the density information for those 4 points. Now for that, we need to know how many points there are. So let's go ahead and grab the length. And I'm going to go ahead and just convert this also to a local parameter. And I'm going to call it point count. Now, of course, we need to also set up our variable. So the ones that are going to be exposed. So for that, I need to create a variable, call it amount of points, or maybe something like, or selected point quantity. You could name it however you'd like. I'm going to change this to a integer because we can never select a fraction of a point, and we're going to expose this. And if you're wondering, the reason we aren't using the point loop is just because I haven't figured out yet how to get the information that I'm going to be configuring here into the point loop body, because we don't have access to the same information there as here. But from here, what we're going to need to do is figure out if the amount of points that we have selected here, if it's greater than our point count, well, we don't want to be able to select more than that, right? So what we're going to do is grab our selected point quantity and grab our point count. And if the selected point quantity is greater than our point count, we need to store that as a variable. So I'm going to go ahead and convert it to a local variable, and I'm going to just call it selected max points. So from here, what I want to do is take all of the point information and shuffle their order. So the way I decided to do that, and there's many ways of doing lots of things in blueprints, of course, is I'm going to take our point count and I'm going to do a for loop. And I'm going to change the last index to be the point loop instead of our first. So what we're going to do effectively is take our loop and we're going to add it to an array. So what I'm going to do is over here, I'm going to go ahead and just call this index tracker, and it's still going to be an integer, but I'm going to change this to an array. And then I'm going to, at the end of this loop, I'm going to add to this array this index. So what it's going to do is, however many points there are, let's say there's 10 points, it is going to go through all of these points, and then it's going to make an array of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have an array of all the points. Great. But of course, then we want to go ahead and reorder them. So let's go ahead and grab that tracker, and I'm going to go ahead and shuffle the points. So what this is going to do is just take that array, and now it's going to reorder it randomly. So instead of actually having this in order, it is now in a random order. So from here, I need to double check if we have the max count, if the selected max point is true or false. So add a branch, and I'm going to plug in our selected max points. And the reason I'm doing it, I'm not doing this information here, is because at this point, it does get reset, I found, because this goes through multiple times. I found it that for some reason I need to put it back here, then over here. So this is just an easy way of me setting the variable before it starts the loop process and everything. But from here, if it is true, then we want to actually set the selected point quantity to our point count, but +1. So the reason we're doing it +1 is because over here, we're going to do a for loop. It's a regular for loop. And instead of having 0 be our index, we're going to set it to be 1 and plug in our points, selected point quantity here. So that way, when you put in 1 for your selected point quantity, and let's go ahead and set that default to be 1. When you select it to be 1, it is going to go ahead and run it once. If the default here was 0, it would run it once for 0 and once for 1. I'll just set first index to be 1, which is why we're adding 1 when it's max. And in fact, let's get selected point quantity. And for this, I'm going to change the slider range minimum to be 1 and the value range minimum also to be 1. So you can never select below 1. And from here, what we now have is the amount of times you need to go through all of these points. And so we're going to get our index tracker, and we're going to get just a reference, and our index is going to be what it's grabbing. But of course, this is now shuffled, right? So we need to now store this into a new variable. So I'm going to duplicate our index tracker, and I'm just call it indexes to select. And I'm going to add them to this. So effectively what we're doing, based on how many points I have selected, it is going to loop it, and then is going to grab the indexes that I have in our index tracker that we have set right over here, in order from 0, then index 1, then index 2, index 3, and then add them to our indexes to select. But because we have shuffled them, they're now no longer in order. So it is going to select index 3, index 5, index 1, etc. But it will never repeat because we have shuffled it. We're not actually just randomly generating a number. Because if you, for example, was to do a random integer and use this kind of method, and let's say I plugged our point quantity in here, you have a chance of it randomly selecting 1 twice, in which case the amount of doors in our case would sometimes be 2 when you select 2, or sometimes be 1 because it was selected the same number twice. So that's why we're not doing it in this manner. So from here, we're going to go ahead and grab our PCG points. And then for each of those points, we're going to drag this from our completed loop. So once it's done adding all these in, we're going to compare them to our indexes to select. I'm going to grab these, and we're going to do a for each loop here as well. So we're going to do a for each loop into a for each loop. So effectively what this is doing is for each of the points, it is going to also check each of the indexes. And so what we're going to do is check if the index of this is equal to the array element of this. So I'm just going to drag this out, select equals, and I'm going to drag the index here, and then plug this into our branch. If there's an index of 1, but there's no array element of 1 here, then it's going to be false. So if it is true, we're going to go ahead and grab our array element from here, and we're going to set members in PCG point, if it is true. And what we're going to be setting is our density. And for this, I'm going to go to right click and promote it to a variable. I'm going to say density to set. I'll make this exposed. And by default, Pilot default set it to 10. And you'll see why we do it to 10, even though most densities are 0 to 1. In fact, you can't even select a density past that. If I go to density filter, you see it upper bound is 1. If I put 10 here, it doesn't work. But you'll see that we actually get it to work with this. And of course, because it's exposed, we can go ahead and tweak it. But after we have set the density to 10, we need to get our PCG points and set array element. And we're setting it with this information. And our index is the original index. So I'll just drag it across and plug this in. You can see there's our full graph. So for each of the points, it's going to go ahead and check it against each of the indexes to select. And if they have a match, then set the density of that to be 10. After that, this is where we're going to be using this at the very end. We're going to grab our PCG point data, and we're going to set points off of this completed. And the points we're going to be setting is based on the points we just set the elements on. And then from here, it's going to into this add node with the out tag data. And we need to grab the PCG point data and plug this in. Now, to make sure that we keep our tags and pins also in here, I'm going to just go over to the start. And you can see we have those variables. We have the information here. So what I'm going to do is take this and just drag it to the side. And I'm going to promote these to local variables. And we're just going to go ahead and set these right here, just so I don't have to drag this all the way across. But I can go ahead and plug the tags into tags and the pins into pins. This isn't required, but I want to make sure that any tags or pins that we had on the points do get carried over. Now going back a little bit to our true or false, I did forget to plug in our false. So go ahead and take this false and plug this in, because if it is below the maximum, then we want to go ahead and actually just bypass this and run the rest of it. So if I compile and save, that should be everything. So now if I go ahead and take a look at our scene, if I sample our merge node, see we have all our points. But what we're going to do is take these points and plug them into select random points. And here, if I sample it, you can see you have a lot of them just glowing. But what I need to do is just move this around. And then you could see a random one begins to glow once it has recompiled. So from here, what we can do is do a density filter. And if I sample a density filter, of course, we're getting everything except for that one point that is outside the 0 to 1 range. If we invert the filter, we get just that point. You can see, here it is. We're getting just the 1 point, and it randomly selects a different one. If I want to, I can go in here and now select a different amount of points. If I want 3 points, I can select 3, and then I can move this around, and you can see 1, 2, 3, 1, 2, 3. So now we can select 3 random points, which is wonderful. So let's go ahead and expose this to our blueprint. So in our blueprint, I'm going to grab a new variable, and we're going to go ahead and call this total doors. And here we're going to set this to an integer, and I'm going to expose this. And we're going to set the value range start and end to be 1, and total doors here will be 1 by default. And then inside of our PCG graph, I can open this, and you can see all of our points that we have actually set up here, all our variables that are exposed, we can actually plug stuff into. So if you want, you just grab or get actor property, or right click and search get actor property. And we just want to name this the exact same. So we're going to copy the total doors and then plug this into our property name. And then we're going to plug this into selected point quantity. And if I do this, it is now exposed. So now I can change this. But of course, when I change this, it doesn't actually recompile. It has to be regenerated afterwards. So if I do 3 and then move it, we have 3. If I do 5 and then update it, it is now 5. I'm not sure why it doesn't auto updates like the others, but it is a very simple tweak. But and if we go full max, just put in max values and I move this, it just selects all of them, as you can see. So now all the points are selected. So we're now able to specify how many doors do we want on this building. And depending on the building, we might want to set this value randomly at a later size. We might go and check how many points there are total for the ground and go from there. But for now, this is good. At this point, we have our 2 points, but of course, our points are not in the correct location, because if I sample our transform points, right, it is in a slightly different location than in our regular points, as you can see right there. So what we need to do, instead of grabbing it here, we're going to grab it from our transform points. That already has the wall offsets. So now if I sample this and I sample this, you can see here's the point, for example, and I sample it on and off, it's exactly in the same location. So what we can do is grab ourselves a couple of difference nodes. First one being in this order, and I'll stop sampling these transform points. I can just sample these. So you can see this is getting us our 2 points for the door. And if we do the opposite, so if we plug in these two in the source and this one into the difference, and then change, instead of extents, we're going to do absolute. You can see now we get everything except those 2 points. So everything except those 2 points is going to spawn our walls. That's what we had originally. Now, if I was to just plug in the original in here as well, right, we get our full version back. But of course, this is where we can go ahead and swap out our walls to be actually doors. If I go ahead and swap this mesh now with a door, you can see that it automatically has placed a door here, has placed a door here, and in my case, I've selected that there's 2 doors. So here it is regenerated with 2 different doors. If I move this a little more, I see 1 door there, 1 door there, right? And I can move these around, and there's 2 doors on this side, but there's none on the other sides. So I can go ahead and specify how many doors I want. If I want only 1 door in this building, actually let's go 5 doors in this building, I can go ahead and just regenerate this a bit, and then 2, 3, 4, 5. So there you go. So there's 5 doors, 3 of them being on this side entrance. But as you can see, it's not affecting any of the other floors. It's only on the first floor that we're getting the correct amount of doors, and they're always in random position, which is exactly what I want. I want kind of a random effect where I can control the number of doors based probably on the size of the building. So if I have a small building, I can do 1 door. So this is exactly what we want. We're good here. Now let's go ahead and actually take this floor and copy it also vertically into to fill this in. So that way we have a nice actual floored environment. Now to get this floor on every single level that we want is actually quite easy. All we need to do is come down here and grab these copy points and transform points. We'll just go ahead and duplicate it over. So we're going to do is plug in our spline sampler the same way we did here into the source on top, and then our transform points into the target. And if I sample this, you can see now we have the points on every single floor, only where we have the actual floors. So what we can do now is take this, and instead of plugging it at the original location, we'll plug it in at the end. And you can see that now we have floors on every single level. If I stop sampling this, you can see there's a floor there, floor there, floor there. And if we go down to 1 floor, we have the floor on the original. But of course, this is not actually scaled properly. What I want to do is reverse this order. So instead of this transform points being here, I'm going to take this and grab the original spline sampler, plug it in here. And after this transform points, we're going to do this transform points. So I plug this in here, plug that in there. And now we're back to having this scale properly. And if I change the amount of floors, you can see they're now maintaining the scale on every single floor. So perfect. So now I can go ahead and select how many floors we want. We can go ahead and get a floor at every single level. If I go unlit, you can see there's our floors at every single level. We have the specific amount of doors that we want on each level as well. Now we're in a pretty good location. So I'm going to go ahead and just take this, and I'm just going to move it over, because now we're putting it in 2 different locations. I'm going to put it here, and I'm going to comment this, and I'm just call it floor height spline. But now we have a pretty good setup. All that's left to do is kind of set up the roof. If we want to have a flat roof, it's actually quite simple to do as well. So let's do that real quick. For that, we can go to our blueprint, and we can know the location of the roof by just simply knowing what our number of floors is times our height, right? So what we're going to do is come here, come to our PCG graph, and in our floor sampler, what we're going to do is, instead of having every single level here spawn points, we're going to do it just at the very top. For that, take the original spline sampler, and from there, I'm going to transform points. And what we need to do is offset it, right? So what we need to do is grab ourselves another vector. So I'm going to grab ourselves a set vector parameter here and grab our graph instance as we did last time. And for our value, we're going to split it. We're going to grab the amount of floors, and then we're going to multiply it by 300. And that will be our Z. Because our floors are currently hard-coded for 300, so that's what we're going to use. Of course, we need to change the name. And we're going to call this roof offset. I'm going to copy that, compile. And in our PCG graph, we're going to go into our graph settings, add a new parameter, rename it, and just paste in the name. And we're going to change it from a float to a vector. And then we're going to get roof offset. And we're going to go offset min, offset max. So if I was to stop sampling this transform points and sample the original, and then just update the model, we can see that now all the points are on top. So now that we have this, we can actually just plug this, in our case, right in here to get the exact same transform points and mesh, since we're using the same one currently for the ceiling / roof. But in my case, I know I'm going to be using a different one later on, so I'm just going to duplicate this and then plug this in, so that way I can go ahead and swap out the mesh that I used for the floor and a different one for the roof. So there we go. So now we have, again, any shape that we want, any amount of doors we want. The only thing that is missing is this updating dynamically. So if I put 3, I do need to move this. And now I have 1, 2, 3. So there you go. I found this to be a little bit better for what I want to do with this, which is to use this for a full city. And if I'm procedurally making a full city, I want to procedurally place doors where I want them. And if I populate buildings and I have to manually place in overlapping cubes, I found that to be kind of a little bit tedious. So this is kind of more of what I want. It's possible that later on we'll figure out a way of doing it depending on the side it's on. So we'll choose if it's facing a certain way. But for now, I think this will do. So I hope you guys enjoyed it. I hope you liked the new improvements. More to come every single week. So if you liked it, hit the like button, subscribe if you haven't, and I'll see you guys next time. Take care. Bye.